Good afternoon, Ishika. Once you join in, just kindly message. No phone. हेलो आ जाए जी सर शेयर कर दीजिए ओके Good afternoon, Ishika. Good afternoon. What we'll study today, Ishika? If you have not sent anything, so which topic should we study today? Because I need to mention that. So just kindly let me know. Okay, page 15, question number 13679. Alright. So I think it is related to coordinate geometry only. Yes, you send the questions. Page number 15, question number 1, 3, 6, 7 and 9. All right. Okay, so let's start with the first question. Well, topic is, I think, is visible to you also. So question number 1 we start with. 1, 3, 6, 7 and 9. Question number 1, let's start with it. A00, B2 minus 1 and C this, B this is plot BAC and QPR should look like they are of the same size. Find evidence to support this conclusion. Okay. So let's do it. A is 0, 0, we just mark the points. Excuse me. The first point is 0, 0. Minus 1 and C is minus 1 comma 3. Minus 1 comma 3. Minus 1 comma 3. It is the number. So the names of the angles, this point is A, this point is B, and this point is C. Okay. It is minus 1 comma 3, it is 0 comma 0. And this is 2 comma minus 1. Fine. So we have to make the angles BAC. Plot these points. Angle BAC. So it is this and it is this. Okay. So it is like this. Angle is somewhat, this is forming, say it is theta. We don't know exactly what is the value of this theta. Hope you can see it, right? Similarly, the next points are P, Q and R, 8 comma 2. So 2, 4, 6, 8. 8 comma 2. Okay. It is 8 comma 2. And this point is P. Okay. And Q is 10 comma 3. 10 comma 3 is this. Fine. And R is 5 comma 3. 2, 4, 5. 5 comma 3. So 5 comma 3 will come here. So this is R. Okay. Now we have to join angle QPR. QPR. So this and this. So again, say this is another angle forming. Say this is theta 2, and say this is theta 1. So does this look like the same size? And we have to check that whether they are of the same measurement or not. So Ishika, what we can do here, as I think we have studied before, we can find out the angle between the lines as well. If you remember, one formula we have studied, and that is tan theta equals to mod of m2 minus m1 upon 1 divided by 1 plus m1 m2. So I'm just going to write down the formula. That means we have to find out the slopes of each line segments. Say for finding the angle of A, I need to find out the slope of BA, and I need to find out the slope of CA, and then use it to find the angle theta. Good. Similarly, if I want to find the angle this, so I will find out the slope of PR, then I will find out the slope of PQ, and then we'll find out the angle between them. And if the value is coming same, if tan theta is coming same, then we can say yes, they are equal. So hope you're getting what I'm going to do. Did you understand this? We are going to find out the slopes of each small segments, and then we are going to apply the formula. The angle between the line tan theta is given as m2 minus m1 divided by 1 plus m1 m2. Hope you remember that. We have studied this angle between the lines, the formula angle between the lines, where we can write where theta is the angle between the lines. Between the lines of the slope of the slopes m1 and m2 respectively. You can just, this is for your knowledge. Just recall of what we have studied before and what we are going to use. Hope you understood. Right? Good. So let's find it out in the way. We can find out like slope of, we can just write it down, slope of AB. If it is visible, slight bit. Yeah, it's better now I think. Slope of AB if we'll find out, then what we can write? Say 0 of minus 1 divided by 0 minus 2, and which will come 1 divided by 2. Similarly, slope of AC if I'll find out, because I need to find angle A, so I'll find out AC and I'll find out the slope of AB. Hope you're getting this. So it will come, say 3 minus 0 divided by minus 1 minus 0, which will come minus 3. So therefore, tan of theta 1, because I have taken this as theta 1, I can apply the formula m2 minus m1. So it, for example, say 1 is this, I've taken as m2 minus of hope you understood. Just simply substituted it in the formula, and when we'll simplify it, it will come 6 plus 1 7 divided by 2, 1 divided by 2 minus 1 3 minus 1 divided by 2, 2 getting cancelled, and say tan theta 1 value you are getting it as, it is minus 7, or we can say 7. So this is the first equation. We have got it. So angle between them, okay, it's not visible till the end. Let's change it a little bit, the direction. I hope it is clear now. So we found the first equation, and we have found the angle between this two line or these two segments AB and AC as tan theta 1 equals to 7, because it is mod of, we have studied mod of any negative number will always come positive itself. Right. Similarly, we can go for the next one, slope of PQ if I find out, because we PQ we need, slope of PQ, and if I go the slope of PQ, which will come as PQ. So y2 minus y1, so 2 minus 3 divided by 8 minus 10, and which will come as minus 1 divided by minus 2, or it will be 1 by 2 itself. Similarly, slope of PR, if I'll find out, so y2 minus y1, anything I can start with, 3 minus 2 divided by, then it should be 5 minus 8, because that should be corresponding 1 divided by minus 3, or we can say, well, are we doing it right? 3 minus 2, 5 minus 8. Similarly, 2 minus 3, 8 minus 10. Okay. Alright. So it will come minus 1 divided by 3. Okay. So the two slopes we have obtained. And now we'll go with the finding the angle between them. So now we have taken the angle is theta 2. Because this angle we have taken theta 2. So slope of PR and slope of PQ. We are just going to use it. And we can take it as M2 as M1 by 2 minus of 1 divided by 3 divided by 1 plus M1 into M2. Have you written the points correctly? Let me check it out. Because what I think, this should come same. 8, 2, 5, 3, and last is 10, 3. Okay. The slope will come, say 3 minus 2, 10 minus 8, 1 by 2, 3 minus 2, 5 minus 8, which is minus 1 divided by 3. Okay, here if we go with, let's check out whether we have done correctly or not. Yes. Right, we have done it right. So when we'll just simplify it, we can take the LCM here. It will come 6. So it will be 3 plus 2, 5 divided by 6 divided by, and if we'll go with this 6 minus 5, 6 minus 1, that is again 5 divided by 6. Is it right? Hope you're getting it, what I've done. Simplify it will come minus 1 divided by 6. So 6 minus 1, 5 divided by 6, and here also the LCM would be 6. So it will be 3 plus 2 divided by 6. It will come like this. So hence this can be cancelled. Or we can say, which implies tan theta 2 is equals to 1. And let it be the second equation. So from first and second we can derive something. We conclude what? Tan theta 1 is not equals to tan theta 2. And hence what does it mean? Therefore the angles are, although they appears to be same, but they are not same. We can write therefore conclusion. Therefore the angles theta 1 and theta 2 appears to be the same, but are not actually. Did you get it, Ishiva? Do you want me to explain again? You can just write it down in the text. Kindly copy it down. Yeah, please copy it down quickly. Okay, the last part. Okay, should I explain this? So first of all, what we have found the angle between this AB and AC. By this, in fact, the angle would come theta 1 equals to tan inverse of 7. Okay, so this will come as an angle. Similarly, for the second line, we have found tan theta 2, so which is the angle between PR and PQ by the formula this, and which is coming as theta 2 will come tan inverse of 1. Okay, so if this 2 from first and second, what we can say, this tan theta 1 and tan theta 2 values are not coming same. And if they are not coming same, it means what? The angles are exactly not equal. Although it doesn't appear to be same, but they are not equal. That's it. Hope you have understood now. Hope it is done. Be quick, Shika, otherwise we won't be able to cover up all the questions. Yes, please let me know once you are done, quickly. All right. Question number 3 now. Just read it out. So it is saying like this: an equilateral quadrilateral is also called a rhombus. A square is simple example of a rhombus. Find a non-square rhombus whose diagonals and sides are not parallel to the rulings on your graph paper. Use coordinates to describe its vertices and write a brief description of the process you use to find your example. Okay. So well, first of all, we can say we need to definitely just make a coordinate axis, and we have to make a non-square and which is not parallel to the rulings. That means it should not be very much straight. It's written up. It should not be parallel to the rulings. And sides are not parallel to the rulings on your graph paper. So rulings means all the lines which are there, that should not be parallel to them. Okay. Yeah. So for example, I'll go with this. Yeah. Normally, how the rhombus is being constructed? The rhombus is being constructed by knowing the diagonals as well. If we know the diagonals, we can construct a rhombus. Okay. Yeah. Because 4 sides are equal. If we know 2 diagonals. Because diagonals of a rhombus bisect perpendicularly. Okay, bisect each other perpendicularly. So for example, if I know a diagonal, say D1 length I know and D2 length I know. Say for example this is 10 centimeter and this is 8 centimeter. So I can do what? I can just make one line of 10 centimeter like this and another line of, and what we can do, we just draw the perpendicular bisector of it. Perpendicular bisector of it, which will be a line like this, and hence which are not unparalleled to any of the rulings, I believe. Say I have just drawn first diagonal, say this is B, and just made an arc, sorry, made a ray and then cut it, and that comes as BD. So this is BD, the first diagonal, and say this is AC, which is 8 centimeter. So what we did first step, draw BD. I'm just writing steps of construction so that you can just copy it down, because it is also asked you what is the process you took it. Steps of construction. First draw a ray and mark the points BD of, draw a ray BX, you can write BX, and mark a point BD of 10 centimeter. So first diagonal you have drawn, BD. The first diagonal is drawn. Then second step, draw the perpendicular bisector. Bisector of, I think this portion is also visible to you, of BD, which intersects it at O. For example, like this. Okay. So if it is a perpendicular bisector, then what we can assure, what we can be sure of? We can be sure of two things. First of all, it is a perpendicular, it is a bisector like this. Two things are very much clear. Okay. Then what we can do, from the point O, of mark the arcs on the perpendicular bisector of length how much? Because another diagonal is of 8 centimeter. So but always 4 centimeter should be on this side and 4 centimeter should be on this side, because we know that the diagonals of a rhombus bisect each other. Okay, so from the point, mark the arcs of the perpendicular bisector of length 4 centimeter as the points A and C. As the points A and C on the opposite sides. But obviously it will come opposite sides only, because it is on, should be of 4 centimeter from O, and say this is, it's going to come like this is say 4 centimeter, and say this is 4 centimeter, and say considering this as point A, this is point C, and simply join AB, join AD, join BC, and join CD. So what you can write now, join AB, AD, BC and CD to obtain the required figure. You can write. Okay. To obtain the required figure. So if you just join it, let's just join it differently. So hence the obtained figure is a rhombus, and it is non-parallel to its sides, and its diagonals both are unparalleled to the rulings of the graph, I believe, and as well as like the required things. Which are the required things here? Everything we have obtained. Hope you understood. Okay. And what else they're asking? Let's check it out. Okay, use coordinates to describe its vertices and write a brief description of the process you use to find the example. Now we have to write down the coordinates as well. Okay. So for writing the coordinates, what you can do, now again we have to use some concept of coordinate geometry as well. For example, this point I have taken as 1 and say this is also 1 on this side. Okay. And this length should be 10 according to this. It should be 10. Okay. So this is 10, and if I'll just go ahead with it, and the point here will come something, here it will come something. So if we just form a triangle, right angle triangle, then what you can say about this, if this point is x comma y, then this length is 10. This would be, how much this length would be? This would be y minus 1. Hope you're getting it. If this is y and this is, so this length would come y minus 1, and similarly this length would come x minus 1. Hope you're getting it. Right? Excuse me. So I'm starting with, say, point B is 1 comma 1, then say point D is x comma y, then what I can say, the length BD is actually 10. Okay. So BD would come as x minus 1 whole square plus y minus 1 whole square equals to 10 square. We can write it like this as a distance formula. We can apply it. So from here we are actually getting it. You can get it by, in GeoGebra you can easily get the coordinates. Okay. It requires a lot of solvings for doing it, and I don't think that this question requires it should be done by GeoGebra, what I believe. Construction you can just make it, and just make any oblique line. One thing I can do, I can just make an oblique line, say for example it is forming an angle of 30 degrees from here. So I have a slope of this line, I can use this concept as well. Say for example this is making a 30 degree, so slope of BD, I can just use it. So slope of BD will come tan 30, and say which is, say this is m1, which is 1 divided by root 3. So according to it, say y minus 1 divided by x minus 1 will come 1 divided by root 3, and from there y minus 1 into root 3 equals to x minus 1. Okay. And therefore we can write therefore, which implies visible? No, not visible. Okay. Which implies x would be equals to root 3 times of y minus 1 plus 1. So it will come as an equation of this line. Okay. Alright, equation will also help us. So this is the equation of the first line. Second equation can be, so So now we need to put this point here. So it's going to be a very lengthy solving. Huh. Yeah, please just understand the process and then do it. The finding the vertices can be done by the help of GeoGebra very easily. Otherwise, it will be a very big calculation. It will cover the entire board, I believe. Because now, like I have got the value of x, so this I will substitute in the value of, in this equation. Then I will solve it. It will become a quadratic equation, which is a big one. Then we have to solve it, get the value of y, and then get the value of x. Once we obtain this, then we'll try to obtain the points A and C as well. So it is going to be quite lengthy. Okay. So just use the same bifurcation, same lengths and everything, and just use it in GeoGebra. You will easily get the vertices. All right. So you can just copy it down. If it is clear to you. Did you understand how we have constructed this rhombus? This is more important. All right, please note it down. Yeah, alright, Ishika, may we start with the next one? If you are done. Alright. Going with the sixth question, Ishika, there's something like again with the coordinate system, we have to plot the coordinates, and yeah, let's go ahead with the coordinates quickly. is and 0 0, the first point. Second L is 7 comma minus 1, 7 2 4 6 7 7 comma minus 1. So point L is, and M is 9 comma 3, 9 comma 3. So it will come here. So we have to join the triangle KLM. Fine. Similarly, PQR, P is 6 comma 7, 2 4 6 6 comma 7. This is P 6 comma 7. Then another is 10 comma 5. And R is 1 comma 2. So triangle will come something like this. Alright. So these two are the triangles drawn. Show that neither triangle, show that the triangles this and this are congruent. First one you have to prove they are congruent, and then neither triangle is a vector translation of the other. Describe how one triangle has been transformed into the other. So that we can do. Fine. So how can you prove them congruent, Ishika? So for proving congruent, either we can find out the length of all the three sides, because the coordinates are given, and we can prove it. Yes, two respective sides are equal to, like all three respective sides are equals to the corresponding three sides, and then we can say they are congruent by SSS. Or we can just find out the angle between one of the angle, and then check out which angle would be equal, but that would be a tedious process. What I think that distances would be easier one. Okay, because if they are congruent, then all the sides should be correspondingly equal to each other. So we'll just find out, we'll start finding the sides, length, say PQ. If I'll find out PQ, and quickly we can do it. How? 10 minus 6 का whole square, that is a 4 का square, that is 16, plus 5 minus 7, that is minus 2 का whole square, that is 4. So it will come square root of 20. We'll leave it in the square root set itself. Then we'll find out PR. So PR will come 6 minus 1 whole square, that is 25, plus 7 minus 2 whole square, that is again 25, and that will come square root of 50. And similarly now we'll find out QR. So QR will come 10 minus 1 whole square, that is 81, plus 5 minus 2 whole square, that is 9, so this is coming square root of 90. So we have got the length of the three sides, PQ, QR and PR. Similarly we can find out the length of KL. So KL will come as 0 minus 7, that is 49, plus 1, that is square root of 50. Similarly LM, if I find out LM I can get it 9 minus 7 the whole square, that is 4, plus minus 1 minus 3, that is 4 again, 16, and that is square root of 20. Fine, good. And if we go with MN, let's find out the last side. So Mn will come as 9 minus this 81 plus 3 minus 0 whole square, that is 9, and square root of 19. So hence you can see, like, yes, they are equal. We can write now. So in triangle, we can start writing like this. In triangle KLM and triangle PQR, what we can say first is equal. KL is equals to root 50, it's PR. Then say LN is equals to, we can just write it down, that is square root of 50. LN root 20 is equals to PQ, which is equals to square root of 20. And if I'll go with Mn, which is equals to square root of 90, which will be equals to QR, and that is this. Hope you understood. So from this, therefore we can say, therefore triangle KLM, if I'll take this, congruent to, so KL, if we'll see, the KL is equals to PR and LM is equals to PQ. So definitely the P point should come in between, then it will come R here, and then it will come Q, so that Mn if we check, not Mn, KLM, it's MQ, sorry. So MK should be equals to QR, yes, MK should be equals to QR, and which is this. So they are congruent by SSS. Did you understand this much? Ishika. All right. Now what is next? How the second triangle is formed? Question is this: how the second triangle is formed? Then I can say which sides are equal. Let's just mention it in the figure as well. KL is equals to PR. KL is equals to PR. LM is equals to PQ. LM is equals to PQ, and MK is equals to QR. All right. Fine. So yes, if we just take this triangle and put it over it, for example, there are two pieces of triangle, and if I'll just pick it up and put it over it, yes, they will exactly overlap, and that is the meaning of congruency, right? So they will exactly overlap. So question arises how we can get it by them. So if I'll shift this, for example, I'm just going to shift it 1 point here and then 2 points above. Will it appear, and then flipping it? Yeah, it's not the vector translation, but I can say what I can do here. The process comes out to be like this. I'll just write it down. The process is this: first of all, 1 unit right, then second process 2 units up. We have to shift. First one 1 unit right, 2 units up, and then flip. So this is the first process to be done, this is the second process to be done, and third comes out to be flip or rotate the triangle. Rotate, or we can say just turn the triangle. Flip would be the correct word. Flip the triangle. Flip the triangle, flip the second triangle, or flip the triangle KLM, which will exactly overfit triangle KLM we started, which will be triangle RPQ, which will exactly overfit triangle RPQ. Okay, so this can be the process. It's not a vector translation, but what you can do, because we can see like this is 9, this is 10 here. The 1 unit right we have to shift, and we can see it here also. It's 0, 0, it's 1. This point X is only 1 unit right on the side. So 1 unit right we can do, then 2 units above we can do, and then flip the triangle, because this coordinate would not match. This is just flipping. So when we flip it, then it will fit it out. So these two units, these two coordinates can give us the clue. Okay, and just check it out in GeoGebra. Is it working in the same way or not? Hope it will work. Okay, so please note it down, and if any doubt is there, kindly just let me know. And just please be quick and write it. So 7th question, we can do it right now only. Yeah, please follow it down. I'm just writing the 7th question as well. Yeah, you can do it. That does not require any graph or something, so you can complete it here itself. Yeah. So Ishika's 7th question is very simple. They are asking about, say, what is this line, and you have to find out the slope of the line first, the very first thing. So we know that from the equation, if I want to derive out the slope, then what we will do, we will first of all convert it in this form, y equals to mx plus c form, and then we get it like this. So we are trying to make y as a subject, so shifting all the x terms on one side and then dividing it by b, and we get the slope. Slope is what? M. So M is slope, so the coefficient of x is slope. So I think you remember this. This much we have done already before many times. Now we need to get the line which is perpendicular to it and passing from the origin. So for example, a line, this line is ax plus by equals to c, and we have to get the equation of a line which is perpendicular to it and also passing from the origin 0, 0, or we can say it is passing from this. Hope it is visible to you. So we are targeting, say this line is L, so and this line is P, so we are targeting to find out the equation of line P. So we can write for the equation of P, for the equation of line P, we can write, say this line has a slope M2. The first thing which we can write, since L is perpendicular to P, therefore M1 dot M2 is equals to -1, or we can say the slope of the second line will come -1 divided by, and the slope of this line -a divided by b, or which will come b divided by a. So slope of the line we have got it as b divided by a. Ishika, just let me know if it is not visible to you, anything like here. I think it is visible. Right. Adjust it a bit from the top. So this much only, till here only I'm writing. I'm not writing behind this, like below this. So once we have got the slope, then what we can use, we can write now for the equation of line, we have x1 comma y1 as 0 comma 0. So equation of line can be written as, equation of line will come y minus y1 equals to m into x minus x1. We can use the slope point form. Hope you remember that. So y minus y1 is 0, m is b divided by a, and x minus x1 is 0 again. So if we cross multiply, it will come ay equals to bx, or we can write, it implies ay minus bx equals to 0. So hence this will come as an equation of the line, ay minus bx equals to 0. If it is not visible, then let me know, and if it is not clear, then also let me know. Otherwise, please copy it down. Yeah, please copy it down. Let's move on to the 9th question now, quickly. Which one is not visible? The 7th question is not visible to you? Hope it is. The last line, it's the right side, only the last line comes out to be ay minus bx equals to 0. That's it. I have not written anything beyond that. The equation which I made it in a box, it is ay minus bx equals to 0. That's it. Hope you finished copying. So let's start the 9th question then. So if you read the 9th question, it is saying that the one or two corresponding parts, knowing one or two corresponding parts would not help you to construct another congruent triangle, and that is true. We have discussed it in the last day. So we have to make a table now. We have to make a table in which all the things, necessary conditions would be mentioned. So we'll just make a table here, the condition for congruency, or conditions for congruency of a triangle. Of triangles. You can just write it down as a heading. I think it is not visible at the top. So condition for congruency of triangles. And so here I'll write down the conditions. And here I'll just write down, say, first condition if I'll start with, it will come SSS then second would come SAS, third would come ASA, fourth would come angle side, and the fifth would come RHS. So hope you remember all these conditions. Corresponding parts to be equal. I can just write down the next heading, corresponding parts to be equal. And this next heading, this can be a serial number. So a table of 5 cross 3 you can make, 5 cross 3, 5 rows, or in fact 6 rows and 3 columns. Okay, so condition is coming as, you can just write it down in the correct thing. All the three sides correspondingly. Because I've written corresponding parts to be equal, then all the three sides correspondingly should be equal. Coming to the second one, two corresponding sides, because corresponding word is already written, and the included angle. You can write like this, and the included angle. Okay, so when it's coming as SAS, so it is two concluded sides, or two sides, any two sides correspondingly should be equal, and their included angle. Okay, coming to the next one, two angles and the corresponding side, and the included side. The side between them should be equal. It is the third one. Like if I make a line, it's two, yeah, so that you will not get confused. Now angle side means two angles and unincluded and non-included side. Non-included side, that will also work. Any two angles and non-included side, or we can say the third side, but always. Okay. And right angle, this RHS stands for what? So we can say in right angle triangle. It is especially for a right angle triangle. First of all, a right angle hypotenuses, because both have the two hypotenuse, so we can say hypotenuses, and any side, or we can simply write hypotenuse and any side. So these three parts, if correspondingly become equal to each other, then we can say yes, this condition works. So these are the 5 conditions by which the two triangles can be proven congruent. Okay. So what next is asking in the question, it is asking, create a table of the possibilities. Which do you think will work and why? Realizing that one or two corresponding parts do not ensure for congruent triangles in the juniors, conjecture. So I think in the junior, the one which we have done on the Sunday, he has measured one side, or he has measured two angles, right? So when one side was measured, we can start writing like this. First condition, when one side was measured, because there were two conjectures. First, he has measured one side, so if one side was measured, then which one can work? I think SSS would also work, ASA would work, or in fact I can say ASA and angle side would work, because he has measured one side. So anything, in fact, if when one side was measured, then ASA or AAS, In fact, SSS and SAS can also work, because then he has to measure the other two sides as well, or other side and other angle as well. So considering that only one side was measured, now he can measure two other angles, then this would work. Okay, will work. So this is the first conjecture. And the second one, when two angles were measured, then also I think this ASA, because one more side is required, and AS will work. So in both the cases, ASA and AAS would be easy go to make a congruent triangles. If I'm just going with the conjecture which you have sent on Sunday, the question, I'm just going with that question when juniors want to form a triangle, and they just measured one of the side, and they just measured any two angles of the triangle. Right, Ishka? Hope you understood. If not, then just let me know if anything is unclear. Please copy it down, and I think this is enough for the day. You can wind up the class now. Just let me know once you finished copying. Alright, Ishka, thank you. Thank you for the day. Bye. Take care. See you in the next class. Bye-bye.